My name is Mr. Warden. I've taught engineering and manufacturing for the previous 7 years, and I'm also a tool hoarder. My goal is to have literally one of every tool that exists, including all their variations, attachments, and accessories. I like having the right tool for the job, and if I don't have it, I make it, or buy it. That being said, here are 10 tools that most people probably haven't heard of, but can be very useful to anyone who makes stuff or does DIY or arts and crafts. The Rasp. A rasp is very similar to a file, except it's very, very rough. It removes material exponentially faster than the file. A file is typically used to remove material from wood and metal, probably plastics. The finer the tooth, the less material it can remove per pass. So let's consider the theoretical maximum of that relationship. At a certain point, as these file teeth get bigger and bigger, we eventually end up at the rasp. The rasp allows us to remove larger amounts of material quickly, but it's basically just for wood. The reason a file is able to remove material from metals is because metal basically is brittle. Rubbing the file against the metal causes the atoms to heat up, and any rough surface area on the metal will harden, shatter, and break off in the course of a single stroke. For much the same reason, it's easier to remove material with a file from the corners rather than a smooth face. When it comes to the rasp, the surface areas that we're attempting to modify are much too small on a piece of metal for the rasps to get anything done. The rasp's teeth can't obtain any kind of purchase, and even if it could, the amount of work we can impart on the rasp teeth isn't enough to overcome the bonds that are keeping the metal atoms to the overall piece, and so nothing will happen. Wood, in contrast, is soft and we can slightly compress it, which allows this rasp tooth geometry to catch little wood fibers here and there. The rasp teeth grab the wood fibers, pull and tear the fibers off the larger piece of wood. This works with a file as well, by the way. As such, we can do things like this. This is an art in and of itself. Dentist's tools. When one makes things, we find needs in strange places. How many times have you been trying to press down a very small piece of tape into the corner of a piece you're painting? How many times have you tried to sit and scrape residue or dye off of a small circuit board so that you can see? How many times have you tried to push your fingernails up under the case of a device you were taking apart? The set of dentist tools is cheap and so versatile. No workshop can be without the set of dentist's picks. They are small, they are delicate, but tough enough to keep their shapes. They are nearly disposable in their cost, and if you need to really dig into something, you don't have to worry about breaking it. Great for scrapbooking and pressing down little fiddly sticker corners, great for moving around exceedingly tiny electrical components, great for working on 3D printers. It's a tool in the most ideal sense. It's made to do work on stuff for a purpose. The Solderless Crimp spade connector. When we work on electrical stuff, inevitably we find a situation where we have a wire that is too short, or two wires that need to splice into different directions, or two wires that need to connect. You can sit and solder it together, wherein you melt a low-temperature tin into the copper wires of both ends and melt them together. The circuit's integrity is maintained and it's relatively permanent, unless one was to remelt it. But this comes with a host of problems that bother me. For one, I make hundreds of mistakes in a given project, and so a permanent solution to a problem is never my favorite idea. I would always prefer a mechanical connection because inevitably, maybe months later, I'm going to need to redo it. Most of you know I'm currently restoring a 1991 Chevy G20 van. Part of that meant I had to rewire the entire car from scratch. Imagine my frustration when I soldered two wires together only to realize later that it was tangled around the brake pedal, and I had no way to undo it besides cutting the solder joint out and redoing it. That bothered me so much that I went and looked for another solution. Enter the Solderless spade crimp connector. Here's how it works. You have two wires that need to connect to each other. You choose two of the same colors. They're standardized as red, yellow, and blue. They're colored that way because the crimpers you buy are also color-coded. These are the cheap kind. These are more expensive. You take your wire, slip it into the connector to ensure a valid connection, choose the divot here that matches the color, and very firmly squeeze the crimper to crimp the connector. The pressure compresses the rubber insulation and it keeps its form. Meanwhile, the metal sleeve inside here is also compressed, which deforms it around the copper wire, keeping everything firm and secure. Meanwhile, you do the same with your other wire, and then the two mating ends now fit together, and you have a relatively sturdy electrical connection that is also reversible. I love these. Gauge pins. Machinists use a lot of very specific tools to do very specific jobs, to remove very specific amounts of material from their builds. One thing we need one thing we need to do is check our work subsequently. How do we do that? I can come in with my calipers and check the distance across the hole, and I can understand that the hole is probably pretty close to 1/4 of an inch. However, what if I need to be sure? What if I need to know precisely what size this hole was? Probably 1/4 inch isn't going to cut it at a certain point. Enter the gauge pin. The gauge pins are precisely ground cylinders of hardened steel, sometimes ceramic, and they come in a set. This particular set has a number of pins at various sizes in increments of 0.001 inches. So if I need to know the size of this hole, I check. Too small, too small, too small, too small, just right. That hole is 0.25 inches in diameter, and we know the next one would be too big. So it is. You can as well buy gauge pins that are exceedingly small, like pencil lead sizes. The automatic center punch. This is a hardened steel point attached to a spring-loaded handle. Let's pretend that I have a piece that I'm working on, a piece of metal, and I want to make sure that when I go to drill a hole that my drill bit doesn't wander. See, drill bits have a tendency to wander and not stay where they're supposed to, for much the same reason as we discussed earlier when discussing rasps. In order to prevent that from happening, I have to give the drill bit something to grab onto. Enter the automatic center punch. I take the punch and set the point exactly where I want my hole to be. I put pressure down and it punches a divot into the metal. If we take this apart, we can see that it is spring-loaded, and so after a certain amount of pressure is applied, the spring slips and our downward force interacts with the hardened steel point and we make a divot. We punch a divot. Now when we go to drill our hole, the drill bit will not wander around. Sanding twigs. They're like sandpaper, or nail files, or sanding strips, or sanding sponges. But instead, they're itty-bitty little tiny strips of sandpaper for those hard-to-reach areas. You get the idea. The forceps. Have you ever needed to grab something tiny and make sure that it stays grabbed? They make surgical forceps in all kinds of shapes and sizes for grabbing all sorts of shaped and sized things. Imagine how complex and interesting the world of surgical tooling is. Think about the small and precise moves surgeons have to make when they're in there. And think about how useful such a precisely manufactured tool would be in your practice. Hamburger paper. This is basically a kind of wax paper. It's much more matte than wax paper traditionally is. The point of using wax paper is to provide a non-burning surface that will allow you to retrieve baked goods off of your pan after baking. It has incredible other uses though. You can mix paint on it and it will never soak into it because the wax coats the paper. You can separate loose leaf sheets and reuse them later. You can keep your tools clean while you press down on something gross like raw hamburger meat. That way you can dispose of the paper and not have to clean the tool. Wax paper is non-conductive, doesn't soak up water, and is cheap and plentiful. The perfect disposable material for a myriad of uses. Worried about your surface finish? Use some wax paper to protect it while you continue to work. Need to put something down while you paint or while you sand? Grab a piece of hamburger paper. Need to draw on it? No problem. It's more matte than regular wax paper and so it takes a pen or pencil line with ease. The plastic bottle cutter. Plastic bottles are a major waste product in our society. With the plastic bottle cutter, I can shred those bottles into a nearly usable textile and a certainly usable rope-esque product. Not only do you gain new materials, but you save this bottle from accidentally ending up in a landfill where it does not belong, which happens a lot. Currently, I'm designing a plastic bottle extruder, which will actually take this line and melt it into an extrudable 3D printing filament. Stay tuned for that video. The power supply adapter with replaceable tips. This is a relatively new tool. I'm not sure who the original designer is. All I know is that the Chinese manufacturers go crazy with this because it looks impressive on the Amazon page. Ooh, lots of pieces. That's got to be good. It is good. It's perfect. It works great and has no issues. You change the tips here and you can plug in a myriad of chargers, connectors, barrel chargers, and plugs. Have you found a mysterious device and don't have the charger to it? This literally happens to me once a week because I take in abandoned and abused electronics and try to refurbish them a lot. The charger with interchangeable tips allows me to test, allows me to troubleshoot, and allows me to figure out what actually the charger is supposed to be that goes in here. The only downside is that it's very easy to fry a piece of electronics if you don't know how much voltage it's supposed to take, so use at your own risk. Finally, the micro drill. The micro drill is another one of those tools that the Chinese manufacturers love because they're easy to make. It's a motor with something to hold the tool, and that's about it. Dead simple to make, looks impressive, looks useful. It's great. What it is great for is not for everyone. It's great for drilling solder holes in circuit boards so that you can put in capacitors or resistors. They're great for crafting miniatures and making custom small pieces like these. That was 11 common tools that you might not know exist. If you did know they exist, tell me in the comments cool tools that you know that I might not know, and if you like this video, I'll make more. Mr. Warden's Workshop is a 501c3 educational charity whose mission is building emotional and passionate intelligence through learning communities. Please consider supporting us following the links in the description, including a tax-deductible donation to our organization. Thank you, and remember to live the curious life.